Good afternoon, students. Today's my class is response to impulse loading. What is meant by response to impulse loading? Response to impulse nothing but very large magnitude of force which is related to the short time. That means very large magnitude of which is short time. That means I will explain to students. We observe the figure. When we observe the figure, very large magnitude for the short time, and this is known as it's a short time impulse loading, and it also known as shock load. Example, best example, bomb blast. If observe bomb blast, if you if a bomb blast is have been blasted here, but the loads will be goes on in this way like this, goes on like this. You observe that this is known as impulse loading. In that impulse loading, they have two phases. The first phase is corresponding load having vibration phase during a load acted. The second phase is following three phases. The maximum impulse load having duration, very long response of phase one. Phase two, short direction occurs in the maximum magnitude. And there are two methods to calculate it. There are two methods. We have two methods to determine the impulse load. The first method is differential integration method and dual integration. Here the differential indication matter. In the differential indication matter, we first of all consider the we first of all consider the sine wave impulse. Sine wave impulse. So the sine wave impulse is when observe a sine curve of this curve shape, where f naught is there, that is called p into sine which is the force and distance between both of them. When a condition 0 is less than guarantee, t is less than guarantee, t1 is equal to this phase duration nothing but mass into velocity into k into distance equal p sine theta. That implies k double dot is equal k by m into x p sine theta. By the solution we can written as then xp is equal to 2p by 2m. That's equal d is where d square is equal to minus d square. Same as xp is equal to xp by where sine theta by t equal d is by k into k by m. That implies P naught is equal to sin theta by omega to omega square, where omega is equal to W by W naught, where omega is equal to ratio of frequency, natural frequency, damping frequency. Then the beta square, then the xp is equal to omega to beta square. Then steady state response xt to xt into xp, xt into xp into xt. Then it will be implies that x naught is equal to W into cos square sin theta p. Yeah. The response at x naught is equal to sin omega t. Then again, DLF is equal to W naught by X naught is plus 1 by T naught square. As well phase 2, where T naught is less than get T1. Then the maximum solution, what is the equation of solution we have? M x double by kx equal to 0. Where xt is equal to x naught is equal to kx into T naught and Wt. Then during second phase, T minus T1, the T dash. Second phase, T minus and the distance between both phases is T minus and T dash. In such a case, xt dash is equal to xt into cos omega t dash is equal to x dot t dash equal to. By comparing both phases, we will get where t is equal to t1. In case t is equal to t1, we will get to dissolution to dissolution. Student, this equation is very large. If you want to explain tomorrow class, also not an issue on that. And final solution is this is the final solution. We observe this is the final solution. By solving all this, we will get the final solution. And triangular impulse. Here we have two phases. In triangular impulse, we have two phases. The first phase is forced vibration, and second is free vibration. That means 0 to t1 time distance travel from force is equal to forced vibration to because the distance travel to force of the object. And t2, t1, t dash is a free vibration. The distance travel freely without any force. The straight line represents y is equal to mx plus c. After y is mx plus c is equal pt is equal minus p naught by t1 by p naught. Then P naught is root of 1 minus T1 by T2. By checking of equation where T is equal to 0, T equal to T1, and P naught is equal to P naught, P is equal to 0. That is T is equal to 0 is the first phase, T less than P is second phase. By combined first phase, mx double r kx and P is equal to T minus T naught. By solving the equation, the complete equation will turn by x xt a w omega t b w omega t and xp. Then apply d square is equal to omega n, then xp equal to omega t square n. By solving out this all equation with the delta omega equal to we get xp is equal to xp not 1 minus t. In same case, the equation may be the equation will be written as x bar of t is equal to sin xt into b by p bar of n t minus t1. The initial equation we taken conditions at x equal to 0, t equal to 0. At t equal to x bar equal to 0. Then the condition will be x t equal to 0 to 0, t bar equal to 0, then p is equal to naught by k. Same second x bar equal to t. By solving this all condition we will get this solution. By solving this solution we get sin omega n ti by omega n ti sin omega, and this is the main solution triangular phase. In first phase only, but in the second phase, already told you, that is equal to what I told the distance between both of them. That means this distance, that means this both distance, right? T, the both distance is equal to T bar. The both distance is equal to T bar. In such a way, cos omega t equal to a sin omega t. Then by solving this all equations, we will get by applying that t equal t1, t bar. A t bar is equal to, by applying that we will get dynamics magnification factor is equal to x bar by x1 equal 1 by omega t. One is equal to omega n by t minus sin omega n t minus t, that is equal to what happened triangular phase. In this triangular phase, the impulse equal to even two phases. The first phase is where 0 is greater than equal to t is greater than equal to 1. The second phase is p not equal to 0, t is equal to equal to 1. Then first phase has a mx equal p naught p naught. Then by solving this whole equation, we will get xp is equal to p naught by k. And d square will be 0 and omega will be 0. The complete equation must be general equation plus particular equation. Understood? The complete equation must be in a form general equation plus particular equation. What the complete equation means? X bar. What general equation means? A omega t plus b omega t n. What is the particular equation? The particular equation xp, which we got in just now. That is equal xp is equal p naught by k. Now applying the condition. What is the condition? Earlier I told the boundary condition. T is equal to 0, x equal to x naught. T is equal to 0, x bar equal to x naught. In such a way, by applying both cases, P is equal to P naught, A is equal to 0, then dynamic magnification will become as 1 minus omega t n, 1 minus omega n t. Same way we consider second phase. And the second phase, this then t minus t minus t right didn't change. That implies general complete equation this one. By applying this all equation, by solving this equation by applying all condition, we will get t is equal to bar n. Thank you, students. I will explain class by tomorrow, remaining class.